this is Arnoud, WizBiz.com, and today we're going up and down and tell you what to do with a Zauberling. Zauberling. That's my own homemade Zauberling. And if you don't know what a Zauberling is, you have to check Fisher Technique, that wonderful construction material with which I made a lift going up and down, which is, by the way, just as back and forth, a recurring challenge for the builder of moving Fisher Technique models. And we start out very easily with a mechanical switch, no electronics whatsoever. This is just changing the polarity to the motor and the thing is going up and down. So we are ready to bring in some electronics and some Fisher Technique Zauberlings with a push button in the far end and a push button down here. So it goes up and down by pushing the buttons and flipping the flip-flop to flip from flip to flop. Or, well, you know what I mean. But after all, there's still mechanical switches that had to be pushed at the far ends. Let's take a look at sensors that don't have to be pushed but are just contactless. Like these LDRs, so-called light-dependent resistors. And there is a modern variant of that, the photo transistor, which just essentially the same. And we have NTCs, temperature sensors. There's also something like PTC, goes the other way with its resistance inside. And we have a water sensor that's lowering his internal resistance when it's getting wet. Here's a modern one, and this is an active one. It has it needs a 5-volt. And well, let's discuss those passive and active sensors. And well, to the left, the passive sensors like these, the LDRs and PTCs, water sensors. And to the right, some active sensors. Active in a way that they need 5 volts to operate. This is an infrared obstacle sensor. 2 variations, share the same PCB layout, by the way. This one going out on a 90-degree angle and this one on 0-degree angle, looking to the front of the module. Very handy and very cheap, very nice. How nice would it be if we can use this with our lifts going up and down to detect the extremes of the motion. And there we have our water sensor, also an active sensor, expecting 5 volts. This is a Hall effect sensor detecting magnetic fields. Perhaps we can delve into that in the future a little bit deeper. Also expecting 5 volts, as you can see, and it just has an output pin that gives you either 5 volt or ground when it detects something. This is a passive infrared module, as we all know it, with 2 potentiometers, one for sensitivity and one for the distance or detecting level of this motion sensor. But it is quite difficult to use with the traditional Fisher Technique Zauberlings, which is exactly the reason most of the time you see LDRs and other passive sensors being used. Which makes me think how great it would be if you could use infrared obstacle sensors or other active sensors and don't even need a relay to switch your motor. Let's build our own micro-controlled Zauberling. Let's go! DIY Zauberling to be used with the traditional ones, with dip switches on the inputs to optionally add a voltage to the voltage divider on the inputs, which is of course not necessary for the infrared obstacle sensors I'm using here, but it is for this switch. So you can use a mix of active and passive sensors on your inputs. By the way, take a look at the video notes if you want to see more about the making of the software and the functionality I've put into this thing. Let's start the motors. You see the dual color LED, red or green on the outputs, signaling the direction of the voltage, and the little blue LEDs, they signal inputs. So this is the top sensor, and now it's going down to the bottom sensor. And by the way, if you're a little bit into Fischer Technique itself, you might recognize this program as being the basic program of Fischer Technique's own ETAC or electronics module. But I've made a small enhancement. You see, it's working just like the basic program that you might recognize, and that's because I have this setting on this little potentiometer to 0. But when I increase the value, you see that the motor direction changes are going more and more smoothly. There are no abrupt polarity reversals anymore at the ends. The direction of rotation is not simply reversed, but it's going through a gradual curve. So both direction and speed are gradually changed. And when we stop it, Mr. Lemniscate in his little chair comes to a smooth stop. Did you like that?
Sure did, mister.
Good!
Ooh, I hope people like this video. Starring me, Mr. Lemniscate. And give it a big thumbs up. Well, you know what I mean.
See you with our next video, and until then, happy hacking!